taking this a step farther, let's look at how the data is actually encapsulated as we move down the stack here. So what we're going to do is our application is going to create some data for us, whatever application it is. So let's say it's a browser. So a browser is going to make a request to a web server somewhere that says we need to get information about this particular website. Let's say it's something simple like Google, right? So I've opened up my browser, it's made a request to the Google website, and it wants to get the Google page. So that'd be the data. Now the application header there, that layer 7 header, is really how the application, in this case our browser, is going to format that data as a request. So this would be the equivalent of an HTTP-based GET request. From there, the presentation layer steps in and particularly formats how that ASCII-based HTTP request needs to be formatted so that the web server understands what we're trying to do. From there, we go down to the session layer. We need to create a port setup so that we can communicate from our host to the web server in question. We get to the transport layer, and now we're actually building the TCP session. So the TCP session is being built. I can establish a communication set between my host with my browser open and Google's web server. As I continue down the stack, now I need to go to layer 3. I need to put the IP address of my host and the IP address of Google. Now, what happens in this case if we don't know the IP address of Google? Well, we start using other protocols that help us out here. For instance, in this case, we need DNS. So DNS would go and do a request to a server somewhere saying, hey, I need the IP address for google.com. And the DNS server would respond back and say, here's the IP address for Google. I could now create my layer 3 header and send my information. We get down to the data link layer, and I'm on an Ethernet network, so I'm going to put a Ethernet header here in the layer 2 segment. I've got a source MAC address and a destination MAC address that I'm going to put in there. And there's also a trailer for this particular layer 2. Not always will you have a trailer for layer 2. In the case of Ethernet, you do, and it's an FCS, which stands for Frame Check Sequence, which is about 99.9% accurate, and it means that any of the bits change, any of the header bits or the data bits change, the FCS algorithm that computes this frame check sequence will change, and then it'll be able to identify that there was change in the data as it was received on the other side and realize the data is no longer valid and got corrupted. So at that point, we convert all of those headers and our actual data into binary. Whether it's encoded little endian or big endian, we have to transmit it on a wire, whether it's electrical or optical or mechanical or binary over avian carrier. You write the binary on a piece of paper and attach it to a pigeon and send it across the world.